besides the first derivative and second. Remember, the first derivative test is for increasing and decreasing, right? The second derivative test is for concave up, right? Holds water, spills water, concave down, okay? So we started this one right here, number 4, but we didn't get to finish it. I did the first derivative test. I know where it's increasing and decreasing. I just don't know where it is concave up and concave down. So I want you to do that right now. So figure out where is it concave up and concave down, okay? Figure out where is it concave up and concave down. Okay, so the second derivative is 72x squared minus 72. So the second derivative test, we have to set that equal to 0. It's a binomial, so I'm going to factor out a 72. And then I'm going to set that, both of those equal to 0. 72 equals 0, x squared minus 1 equals 0. $72 does not equal 0, and you can't solve for it. So this guy is not going to give me an answer. I'm going to get 2 answers. So I go to the next one, add 1 to both sides, take the square root. When you take a square root, you're always going to get 2 answers. So I get +1 and -1. Those are inflection points. Those are inflection points. There's 2 inflection points, one at +1, one at -1. Okay, so I'm going to put those 2 guys on my number line. And then I'm going to plug it into the second derivative, yeah. Yeah, so it's the second derivative test, so we plug it into the second derivative. Plug in numbers less than 1, -1, in between -1 and 1, and greater than. So I got to plug in 3 different numbers. -2 works, -3 works, -4, -10. Yeah, any of those work. The one in between, I'd plug in 0. Yeah, I'd use 0 just so that you don't have to use a decimal. And then greater than 2, or sorry, greater than 1, 2, 3, 4, 10, whatever number you'd like. Whatever is easiest. So if I choose -2, I'm going to go 72 times -2 squared minus 72. So 72 times 4 minus 72. Well, 72 times 4 is going to be bigger than 72. So when I subtract these 2 guys, I'm going to get a positive answer. Positive 200 and something. Okay.
Decreasing means you're doing which derivative?
Plug in 0.
Exactly. So when it's decreasing, what does that mean?
It's 0 minus 72 is -72.
Ones are those, the plus or the
That's positive. Or sorry, negative.
What does concave down mean? Which derivative are you using? The second derivative. And where is it decreasing? Is it concave down when it's plus or minus?
Positive 2.
Area where it's both minus and you overlap them on each other. Where is it minusing on both of them? Right here?
Again, 72 times 4 minus 72.
What are those points?
It's going to be positive. Okay. Now I got to superimpose both number lines right on top of each other to solve this. Okay. So my first number line for the first derivative was up here. Square root -3. or negative square root 3, 0, and positive square root of 3, right? Yep. And then I had minus, plus, minus, plus. Okay. Second derivative. So for this guy, I had negative 1. Well, negative 1 would be right about here, and positive 1 would be right about here. For the second derivative. So less than.
Attention, excuse the interruption. Seniors at this time, will you please move towards the stadium, Hoffman Stadium, which is to the north. Once again, all.
Okay, so decreasing and concave up means first derivative is negative, second derivative is positive. It's going to be right here. Let's see. Wait, and right here. No, right here. Right here too. Those two guys. Okay. So let's write this up. Uh-huh.
Doesn't it say concave down?
Does it say concave down? Did I read it wrong? Concave down, yeah, sorry, concave down. So
So wouldn't it be between 0
negative and negative, right? Yeah, it should be negative, negative. Yeah, thank you. Let me write this down. So we're looking for negative, negative. So that guy wouldn't work. That guy wouldn't work. So negative, negative, yeah, so it would just be right here, right? Negative, negative. So it would be between 0 and 1, yeah. So f of x is decreasing and concave down from 0 to 1. From 0 to 1. That's where they share negatives. Okay. All right. Number 6. So number 6, so it says, so number 6 you're going to change a little bit. It says use second derivative test to find relative extrema. So relative extrema mean relative max and relative min. That's what that means. There's a way you can use second derivative test to do this, but I highly suggest don't do it that way. Do the first derivative test. Use the first derivative test to do it because it's a lot easier. There's a way to do it using second derivative, but don't worry about it. I would say don't even worry about it, just use first derivative. So if they want you to find relative extrema, use first derivative test. Okay, so we're going to use the first derivative test. So this is just review of what we did last week. First derivative, so find the first derivative. What's the first derivative going to be? No. So you're going to use the product rule. So it's going to be cosine times cosine plus, and then the reverse, the derivative of the second, which is negative sine, times sine. So essentially it's cosine of x squared minus sine of x squared. Set that equal to 0. Set that equal to 0. So we got 0 equals cosine of x squared minus sine of x squared. How do I solve this? What's the easiest way? So how do I solve this guy here? Well, what does this mean? What does it mean when I say something squared minus something squared equals 0?
Squares.
Difference of squares. It is difference of squares. Absolutely. But even easier than that. Like if I said something squared, so if I said like something squared minus something squared equals 0.
Oh, just take the square root.
No, not the square root. Think of what all the symbols, all the operations mean. What do all those operations mean? 0. What does 0 mean? If I have 0, what does that mean?
We'll get 0 minus 0.
No, you're getting closer. So don't think about the squareds. Let's take away the squareds because the squareds for this are not important. How about that guy?
They have to equal the same thing.
There you go. They have to be the same thing, right? Anything I have in here has to be in here, right? Has to be. Doesn't matter if it's squared or not, right? They have to be the same. So what you're doing is you're trying to find where are sine and cosine exactly the same. Where are sine and cosine exactly the same? Because if I subtract them and they make 0, by definition, they have to be the same. So I'm trying to figure out where these guys are exactly the same.
5/4.
So yeah, so let's see. There's going to be a couple spots. They are pi over 4. Wait, where's my thing at? There we go. There we go. So sine and cosine. So it's pi, let's see, pi over 4. They're exactly the same. So pi over 4 is one of them. And then the other one is 5 pi over 4, right? Yeah, 5 pi over 4. Okay, so pi over 4 and 5 pi over 4. Oops, where am I at? Okay. But the bounds only go up to pi over 2. The interval only goes up to pi over 2. So I can use pi over 4. And I can even use 5 pi over 4, but I got to change it. I got to change 5 pi over 4 so that I can use it. Because I can only use this side over here. Because this is pi over 2. This is negative pi over 2. So we know pi over 4 is in there. The other one's 5 pi over 4, right? So that wouldn't fit in there either. So the only one we can use is pi over 4. That's the only one that would be in that area between negative pi over 2 and positive pi over 2. So pi over 4 is the only one we could use. Okay, so pi over 4. First derivative. So I'm going to plug it in, plug in numbers, plug in values. First derivative. Let's see. For less than, I would probably pick 0, because 0 is in the interval. So it would be cosine of 0 squared minus sine of 0 squared. Well, cosine of 0 is 1. 1 squared is 1. Sine of 0 is 0. 0 squared is 0. 1 minus 0 is 1. So anything less is going to be positive. Now I got to pick something greater. I'm going to pick pi over 2. No, I can't use pi over 2. I got to use something bigger than pi over 2. I'm going to use pi, because pi doesn't have any fractions for sine and cosine. So I'm going to pick pi. So I got cosine of pi squared minus sine of pi squared. Cosine of pi is 0. Or sorry, cosine of pi is negative 1. Negative 1 squared is positive 1. Oh, wait. But it's got to be in the interval, right? Yeah, so I can't use this guy. Sorry. I can't use pi because it's not inside the interval. I got to use something that's inside the interval that's greater than pi over 4. So I could use pi over 2. I could have used pi over 2 because pi over 2 is inside the interval. So we don't have to change it that much. Okay. So cosine of pi over 2 is 0. Sine of pi over 2 is 1. Negative 1. So first derivative test says it increases before, decreases afterwards. So if it increases, if it changes from increasing to decreasing, that creates a maximum. So relative maximum at x equals pi over 4 because the derivative switches from positive, to negative. Okay. Okay. Actually, I skipped one. I skipped over number 5, so I want to do definitely number 5. Number 6 is just kind of a practice question because it asks you to do all those things. None of those things, or all of those things we've done already. But number 5 is the different function, so I want to do number 5. If we have time, we'll do the last one, but I want to definitely get to this one. Okay, so find all the intervals on f of x when it's increasing. Increasing means when the first derivative is positive. So I got to find the first derivative. Okay, first thing I got to do is find the first derivative. Okay. All right, so So first derivative, I'm going to use quotient rule since it's a fraction. So the low squared and then I do the low times the derivative of the high. The derivative of the high is going to be negative 8x plus 3 minus the derivative of the low. The derivative of the low is just going to be negative 2 e to the negative 2x. And then the top. Okay. That's the first derivative. This is going to be positive since it's minus a negative. All right, so now I got to set the top equal to 0. I got to set the bottom equal to 0. Negative 8x plus 3 plus 2x negative 2x times negative 4x squared plus 3x equals 0. And then the bottom, okay. So the bottom, I have two terms. I have this, and I have this. It's a binomial. Those guys have e to the negative 2x in common, so I'm going to factor that out. Okay, so I get negative 8x plus 3 plus 2 times negative 4x squared plus 3x equals 0. Distribute. I get negative 8x plus 3 minus 8x squared plus 6x equals 0. Combine like terms. Let's see. I'm going to get negative 8x squared minus 2x plus 3 equals 0. Okay, so now I got to continue. Let me continue. Let's see. I'll just do it over here. Okay. Okay, so then set those two equal to 0. So e to the negative 2x equals 0. And negative 8x squared minus 2x plus 3 equals 0. Well, there's no power that's going to make it 0. Powers don't make things 0. Coefficients do. Powers don't. So that guy's not going to equal anything. This guy over here is a trinomial. So I'm going to let's see. So it's going to multiply to be negative 24, add to be 2. So 6 and negative 4. So we get x plus 6, x minus 4. I got to divide by a. So let's see, I'm going to get x plus 3 over 4 and x minus 1/2. So those guys are both going to come up. So we get 2x plus 3, 2x, wait, no, that's wrong. Oh, 4x plus 3. 2x minus 1. So you're going to get negative 3/4 and positive 1/2. Okay. So first derivative test, negative 3/4, positive 1/2. So now I got to figure out where is it increasing, where is it decreasing. I'm going to plug it into the first derivative. So I believe this is going to be positive. I'm running out of room here, so I believe that's going to be positive. Just doing some mental math, positive. That's going to be negative. And this is also going to be, is it going to be negative? This is going to be negative too. So increasing between negative 3/4 and 1/2. There you go. Okay. All right. And then the last one is just a extra practice problem. It's got concave up, concave, it's got critical values, increasing, decreasing, concave up, concave down, relative extrema, where are the relative maximum minimums, inflection points. And so this one I took off a test. It's a FRQ.